AppSec provides a cloud-native WAF with API security, bot prevention, and intrusion prevention. Traditionally, users of WAF solutions had to constantly tune signatures and manage massive amounts of false positives. This led to longer deployment cycles and trading off security by turning off protection. CloudGuard AppSec is a modern application security solution that offers multi-dimensional security analysis that is fully automated with very minimal policy administration. It uses a two-stage enforcement. In the first stage, it is looking at attack indicators like IPs, client-side and user behavior, cookies, and the application session ID. If any of these indicate a suspicious request, it moves on to multiple machine learning engines. It'll then correlate the findings of all of these engines to determine whether to allow or prevent the request. CloudGuard AppSec can be deployed as an external reverse proxy or attached to a web server. In this video, we will deploy a virtual machine with a reverse proxy that contains a nano agent in order to protect our web server. This web server infrastructure is hosting both the web application and API calls for Acme Power. They are a company that allow their customers to view their power consumption through this website once they deploy an IoT device known as Smart Meter on their premises. Web applications like this one are susceptible to many types of attacks. With this SQL engine attack string, I will begin a SQL injection attack against it. Notice how the graph went from recording the amount of kilowatts per hour and the corresponding charges to showing 0. Attackers could take advantage of this to get their electricity for free. Now, if they wanted to profit from this attack, they could also initiate an API attack, which changes the values to negative numbers, thereby crediting their account. Let's deploy CloudGuard AppSec to prevent this and other attack types. I'll start by navigating to the Infinity portal. Click on Add Assets. I'll start with the web application. Fill in the name. I'll choose production for the staging mode because my environment is live. Now paste the application URL and click Next. Now we configure the policy. I don't want it to go into the default learning and detection mode because I know that I'm being attacked, so I'm going to move straight into prevent mode. Now, under normal circumstances, you want to do some of the learning of the actual application, so you run it in detection first and then move into prevention. For the sake of showing the flexibility of the configuration, I'll change my IPS policy to disabled and then choose Next. I'll keep this user behavior learning by default, and now I can choose my deployment method. Choose VM as the method and VMware as the platform. Then input the internal IP of the web application that you want to protect. Click Next, and then Done to publish and enforce this policy. And here's the policy. It protects against the OWASP top 10 attacks, botnets, and IPS if we wanted to enable it. The IPS feature here is based on the same technology as the gateway feature, which got Checkpoint the best grades in independent tests like NSS Labs. I can move on now to protecting the next asset, the API itself. I add a new asset, and this time choose Web API. The steps here are identical. I'll name it, put the stage into production, and paste the application URL before moving on to configuring the policy. I'll put this into prevent mode right away, but this time I'll put IPS into learning mode instead of disabled. User behavior will remain as default. And for deployment, I can actually use my existing profile, which I created when configuring the web application. I put the internal IP address and pick Next. And now I just press Done to publish and enforce this. Because we're protecting the API, we want to upload the API schema file to ensure that every incoming request is meeting the anticipated application use. In addition to schema enforcement, AppSec will also use machine learning to find malicious payload and OWASP top 10 within API calls. Now publish and enforce these changes. Now we need to apply the gateway to actually do this enforcement. To configure the agent, go to Profiles, select VM Deployment Guide, download the zipped folder. Then go into your vSphere client. Select Deploy OVF template, choose a local file, and select all of the files from the zipped folder. Then click Next. Select a name for the virtual machine and a folder and choose Next. Select the destination compute resource and click Next. Click Next after reviewing the template details, and then select the storage for the configuration and disk files. Click Next. Then select the destination network for each source network and click Next. Here, you can customize the deployment properties, such as hostname, default gateway address, admin password, IP address, primary DNS. For the Infinity Next agent token, go back into the Infinity portal, copy the token shown in the Profiles page, and paste here. Click Next, and finally, hit Complete. Once the deployment status shows completed, check in the Infinity portal for a notification that the agent was successfully deployed. We can click on See Agent Details to see all the information about this VM checkpoint agent that is protecting our web server. We can rerun the attacks now and show how CloudGuard AppSec protects against them. I open the power consumption web application and let it run as normal. We can see actual values for the kilowatt consumption and the corresponding prices. I'll use the same SQL engine attack string, but this time, CloudGuard blocks the injection attack. So I'll try the API attack, which changed the value to a negative number. But as you can see, the response code is forbidden. CloudGuard uses the API schema we uploaded earlier to block the illegitimate request. Back in the Infinity portal, I'll go into the Monitor tab, where these events are displayed as logs. This dashboard gives you a broad look into general security events. You can click on anything displayed here to drill down into it. Important events will have critical and high severity logs. We see that the attack against the web API was blocked through schema validation. If I filter to show logs for the web app asset, we see more types of attacks, like remote code execution and different injection types. On the right side is much more detailed information. You too can protect your web applications against OWASP top 10 attacks, botnets, and other attack vectors with CloudGuard AppSec. For more information, go to checkpoint.com/CloudGuard/AppSec.